Alright, today we're going to do a conference on graphing square roots and cube roots. This is actually part 2 of a conference video. First video we talked about graphing the square root function. So again, there are notes that you need to be filling in while you're watching this video. You can print those out on Blackboard, and there's also a worksheet to complete at the end before you meet with your instructor. Let's go ahead and jump in. Again, this is part 2, graphing cube roots. So first thing we're going to do is take a look at the parent graph of the cube root. Now, one thing to take notice of is the domain. The first question then is, in square roots, we saw that we had to have x greater than or equal to 0. Why? Because we couldn't take the square root of a negative number. It would not be real. What about the cube root? Can we take the cube root of a negative number? Well, let's take a look at some obvious ones. So 0 is a perfect cube, right? Because the cube root of 0 is 0. 1 is a perfect cube. The cube root of 1 is 1. And then what's the next perfect cube? So we saw in square roots we want to take good points, so perfect squares. So we had integer values. Well, here, the next cube root is going to be 2 times 2 times 2, which is 8. So the cube root of 8 is 2. All right, so the real question is, what about the cube root of negative 1? Does that exist? Is that real? So is there a number that multiplied by itself 3 times is negative 1? Alright, so yes, negative 1 times negative 1 times negative 1 is negative 1. Therefore, the cube root of negative 1 is negative 1. The cube root of negative 8, for the same reason, is going to be negative 2. So we can see we can have all values of x. So the domain is going to be from negative infinity to infinity. And as we'll see in just a minute, the range is also going to be from negative infinity to infinity. So actually, in doing these cube roots, we've already kind of made our chart. So I'm going to go ahead and fill these values in. We had negative 8, negative 1, 0, 1, and 8. And so those cube roots were negative 2, negative 1, 0, 1, and 2. All right, so we're going to remember this parent graph, T-chart, so we use it in the shifts. But before we do it, let's go ahead and plot this. So if you were just to look at these points in the middle, right, if you plotted 0, 0, negative 1, 1, and 1, 1, you might think this is a straight line, just like we saw with the square roots with the 2 points. So you have to plot some more points. Let's see if 2 more is sufficient. So we could have 8 and 2, and negative 8 and negative 2. Alright, so what you're actually going to find is this is the reflection of the cubic over the line y equals x. Yes, the cubic and the cube root are inverses, just like the square and the square root are inverses, but that's for another video. For right now, we just need to take notice that, again, the domain goes from negative infinity to infinity, and the domain and range go from negative infinity to infinity. So now what we want to do is we want to remember this graph, we'll remember this parent graph T-chart, and we want to take a look at the shifts. So the first shifts we're going to look at again is the left and right shift. Notice these are in the form of f of x equals the cube root of x minus h, where minus h is under the radical. And again, the minus sign in the formula. So here when we have our first shift example, f of x equals the cube root of x minus 2. If I were to write x minus h, it's easy to see that h is 2. So this is the shift 2 to the right. So we want to have a good point, which we saw was negative 8. So we can set what's under the radical equal to negative 8. And if I add 2 to both sides, then I see that I get x should be equal to negative 6. Okay? And if I take the cube root of negative 6 minus 2, we'll get the cube root of negative 8, which is negative 2. Okay, so far, notice the negative 2 is the same as the y column. And let's just take note that if you add it to negative 8, you get negative 6. So I'm actually shifting my x column over 2. Let's try another one to demonstrate that. Alright, so our next good point was negative 1. So we want to again set what's under the radical equal to -1. So x minus 2 equal to -1. If I add 2 to both sides, I get x equals 1. Okay, so, I'm sorry, add 2 to both sides, get equal 1, yeah. So, x equals 1, and if I take the cube root of 1 minus 2, I'm actually looking at the cube root of -1 equals -1. Okay, so again, if I add 2 to -1, I get 1, and my y column stays the same. So I think we've convinced ourselves at this point that because it's a shift left-right, the y column is not going to change. And because we're shifting it 2 units to the right, if we add 2 to each one of these, we're going to get our new x. Okay. All right, so let's go ahead and plot these points. -6, -2. Good. 1, -1. 2, 0. 3, 1. And 10, 2. Okay. There we go. That's our shift. Now, if we look at, compared to our, look at our parent graph, we can see that it's a shift 2 units to the right. Okay, so what we're also going to try in this next shift, the domain is also still -infinity to infinity for both the x and the y. Okay, so our next one, we're going to look at a shift 2 to the right. So now we're going to be smart about it. We're saying we're shifting 2 to the left. Well, first let's take a look. We have x minus -2, right? So if I have x minus h, it's clear to see that h is -2. It's going to be shift 2 just to the left. Okay, hopefully that's clear to everybody. So now, since I'm moving to the left, I'm not affecting my parent graph. I'm actually going to take this whole column and I'm going to copy it over here. I'm not shifting it. I'm not shifting it up or down. All I'm doing is shifting it to the left. So to the left, I'm actually doing what? I'm subtracting 2, right? So if I subtract 2 from each one of my x column, I'll get my new x column with the shift. So -8 minus 2 is -10. Okay? -1 minus 2, -3. 0 minus 2, -2. 1 minus 2, -1. And 8 minus 2 is 6. So my claim is, and let's just go ahead and pick one set of points just to double check. So if I picked x to be -2, okay, if I put x plus 2 under the cube root, then I get the cube root of -2 plus 2, which is the cube root of 0, which is 0. So again, I get my point, -2, 0. So we are correct. Let's go ahead and plot these points. So -10, -2, -3, -1, -2, 0, -1, 1, and 6, 2. All right. Okay, good. So there. But you get the basic idea. This is going to be the shift 2 units to the left of the parent graph. All right. So now we're going to talk about shifts up or down. Just like we saw in the square root function, this is going to be a plus k outside the radical. There's a direct correspondence. That means if k is 3, it's going to be a shift 3 units up, right? This being said, this is not now moving left or right. So we can say that our x values are going to stay the same since it's not moving left right. And what we're going to do, we're going to add 3 to all of our y. Okay, so -2 plus 3 is 1. -1 plus 3 is 2. 0 plus 3 is 3. 1 plus 3 is 4. And 2 plus 3 is 5. All right. So let's go ahead and plot these points. -8, -1. negative 8, 1, negative 1, 2, 0, 3, 1, 4, and 8, 5. Alrighty, there we go. That's a shift 3 units up from the paragraph. Now let's make an observation. If I were to plot my paragraph, again I had the 0, 0, negative 1, negative 1, 1, 1, I had 8, 2, and I had a negative 8, negative 2. Okay? So if you look at these points, they're exactly 3 units down from each one, or a few units up from each one. So when we look at our next one, I do want to take a look at just shifting the points. Now look at the domain. The domain is still negative infinity to infinity, and negative infinity to infinity for the range. So that's not going to change any of these shifts. Alright, this time I want to go ahead and plot the paragraph points. 0, 0, negative 1, negative 1, 1, 1, 8, 2, and then negative 8, negative 2. So again, we claim that this right here is going to be a shift 3 units down. Okay. The main range is still going to be negative infinity to infinity. Because we're shifting it up or down, we're not moving it left or right at all. So our x columns is going to be the same as our paragraph. Okay. But actually what I want to do here is I want to show that if we take the point on the paragraph and we were to lower it 3, right, lower each point 3, what we're going to get is our new graph. And we can go ahead and verify a couple points. You know, so we want to verify this one right here. So we should be, well, if we had the cube root of x minus 3, and we take negative 1, so you have the cube root of negative 1 minus 3 would be negative 1 minus 3, which equals negative 4. Okay, so technically this point here better be negative 4. Well, if I go to negative 1, and I look, sure enough, this point right here is negative 1, negative 4. Okay, so that works out good. And then we can also check it another way. Let's say, I think this last point here, we said, of course, the x column is going to stay the same. Since it's shifting down 3, technically I would subtract 3, so that should be negative 1. Well, is that the case? Sure. Right here is 8, negative 1. And that is also the point on our graph. So, there you have it. There's shifts left, right, and up and down. And I believe we have come to the end of our Part 2 video for our workshop. Again, please complete your worksheet and turn it into instruction. Thank you. Thank you.